Okay, everyone, I think we're good to start. Let me get my video here so we can start rolling this. You should be seeing my video right now. If you have any issues, please let me know. Welcome again. Welcome to the session. This is our cloud security webinar, Foundations and Concepts. My name is Arturo. I'll be your trainer today. This is an hour session, 45 minutes to an hour, including some questions and stuff. We have the chat open, so if you want to ask anything, feel free to. We also have the questions and answers section where you can drop any specific question regarding the topics or whatever you have in mind. And we will have 3 polls running during the session, so please keep an eye on the polls. I'll be letting you know when we are launching one of those, but it's just for you to be aware of that taking place. Give me a second. Let me start here my timer so we can start on time. And again, welcome. What we have for today, folks, before I introduce myself, I would like to give you some context of the agenda, the plan for the day. We have for this class 3 main topics. As you know, this is a cloud foundational class. So basically what we're going to do is discuss a few things regarding security, right? Like best practices, some of the key features and stuff. But we're going to divide this in 3 main sections. First of all, IT security and common threats. This is something that you may be familiar with, you may have seen before, you may have used or dealt with before. So this is more like an introduction topic. Then we will discuss about security in cloud. We will actually see some of the best practices and topics. And at the end, we will wrap up with that actual list of best practices. Okay, remember this session is being recorded, so you can consult later if you need to. Before I get into the actual topic, my friends, first of all, let me introduce myself so you know who's talking on this side of the cam. My name is Arturo Hamilton, as I said. I'm a technical trainer, a cloud trainer. You can scan the QR code and that will get you to my LinkedIn. If anyone wants to connect, I'm there for all of you. I'm a multi-cloud architect. I'm certified in the 3 main vendors, at least in this part of the world, Microsoft Azure, AWS, and Google Cloud products. I've been teaching for more than 8 years now. I've been a technical trainer, a cloud trainer for a long time now, but I've been on the IT field for more than 17 years. I started working as a database steward back in the day in the UK. I was working on a bank based in Leeds. That's 2 hours north from London. I was there for a few years, almost 10 years, and I had a chance of jumping around different locations and positions. So I had the actual opportunity of using cloud as part of my business as usual when I was there. And today, well, I deal with cloud every day. That's what I do every day. And since 2016, I've been working as a speaker. I've been teaching and speaking out for a different type of conferences around the world. Before the pandemic, we used to have a lot of these type of events taking place on site. Now we have changed that a lot into more of a remote experience, but nevertheless still amazing. And I'm also an independent cloud consultant. I have a small consulting company. I run some business based on cloud for customers. And well, that's what I do in most of my professional time. As part of my free time or personal time, I love photography. I've never been paid. I've been published a couple of times, but I never got paid. So I'm just a hobbyist, not a professional. I love to watch weird movies, indie movies. Something that you have as a recommendation will be appreciated. I love to read. I love comic books. I love video games. I actually have a comic book shop / coffee shop / collectible shop online. So that's where I spend most of my free time. Okay, so that way you get to know me a little bit more. For those of you who just joined, you can scan the QR code. That will get you to my LinkedIn. Anything you need, I'm there for you. Okay, but that's enough of myself, folks. Let's get into our subject. Let's start talking about security and then discuss some of the cloud foundations that we have for today, right? That's why you're here. So first of all, what is security, folks? I know this is a concept that can be quite broad for everyone, right? If I ask you, we can take the next 3 hours here discussing the definition of security. So let's put something like a book definition on the screen. It's a practice of protecting. It's the actual matter of taking care of our systems, our data, our information, and making it safe with all the different layers that comes in mind, right? Like networking, data, accesses, control, everything that we have, it's related to security when we talk about technologies. A couple of numbers here that you can see on the screen. We have today, 2023, we have more than 85% of businesses running in cloud. Important, we know that this changed because of the pandemic, right? A lot of business processes, workloads moving to cloud to leverage the actual remote option. So that's a thing. It's important we know that because we're talking about security here for cloud. So just to give you some idea, it's a consideration that by 2026, that's 3 years or 2 years and a few months from now, around 20 trillion US dollars will be the cost of cybercrime and security related issues. That's a lot of money, right? What we need to actually focus on is reducing this amount of loss that we as a user or we as a company might have to face today and in the future. Another important fact here, 80% of all the security related issues, data breaches and stuff, are actually based on organized crime. That's another thing to consider. So we have to have proper defenses, right? And as we can see on this slide, since we have a lot of cloud related topics, we need to know how to work with cloud. That's the most important part. I'm going to start launching the first poll, folks. So you'll see it there on the screen. If you help me there adding some of your answers, I'll be ending it in a few minutes, 5-10 minutes. So most of the cyber attacks we face today, folks, are actually based on things that we deal with every day on business as usual, and we don't even know. We have a list in here. I'm going to explain a few of these because these are the most common attacks when we are working with cloud, okay? DOS or DDoS, depending on how do we approach it. We have the account malusage and hijacking, the actual malware injection. We're going to discuss all this. Insider threats, that's an actual big thing, and the side channel attacks. I'll explain this and we will discuss them. If you have any questions, remember we have the chat, we have the QA open, so please let me know anything I can help you with or answer. I'll be glad to do. But let's go into this specific type of attacks that we might face. Distribute denial of service or denial of service. You may think, I can't recall seeing that acronym somewhere. Believe it or not, every time you have an issue with a daily live platform that you may use, let's say a streaming service, a video game service, an entertainment platform, and you see that it's slow, you see that it's not responsive, you see that you cannot log in, or you see that it's actually completely frozen, most of the times we're facing something like this, a denial of service attack. It's basically someone or a group of people that's distributed trying to clog the system, attacking the system or asking for something, for a response, for a request, for a video, for something, simultaneously, so the system gets clogged. And the regular users like you and me are actually having issues to get the response we're expecting. Think about a video game. If you try to log into a video game and the video game is down, that means that there is an attack. Cloud, my friends, suffers from this a lot. Why? Because we're talking about an online access. Anyone can access the cloud with an internet connection, wherever you are, as long as you have a connection with your device, and you don't have to have a computer. It can be a mobile device, it can be a video game console, it can be a smart device. You can connect using a smart fridge, a smart TV, right? So now imagine a million users trying to connect to your favorite gaming service, to your favorite streaming service, all of them at once to the exact same location. That's a DOS, folks. Cloud is prepared to use this. There are a lot of things we can use. We can use an antivirus, we can use a firewall. But in reality, and that's something that we should consider, there are some cases where cloud will offer you specific tools to mitigate this. We will discuss this later on the cloud tools in a few minutes, but it's important we know this is one of the most common attacks. The second one, and we have dealt with this since the beginning of technologies, it's the account hijacking. How many times you have read, you have seen, you have known, you have been told about someone losing their account? A friend of yours, hey, I clicked on the wrong link and now I don't have my password, or someone is in my account. How many times a friend of yours or an acquaintance came and said, hey, I think someone hacked my Facebook account, my Twitter account, my Google account, whatever. That's an account hijacking. The idea here is that the attacker somehow manages to retrieve your password or to get access to your information to block your access, your actual usage of the tool. We can solve this by protecting the account, stronger passwords, multi-factor authentication. I'll discuss this later. The idea here is that we protect the account to protect the access that that account has. That's the second one we have. Another one that is quite common, folks, that I think you might have dealt with in the past, even on a personal level, is the malware. How many times you have downloaded something and you see a notification saying the file might be infected or the file might be a potential harm to your device? That, my friends, could be a malware. The malware basically tries to disrupt the functionality. In cloud, folks, based on what we discussed a few minutes ago, when I was mentioning the online access, it's something quite common because everything can access everything. Everywhere is accessible for everyone. So it's important we consider, hey, how do I protect two computers from infecting? Do I put them together? Do I segment the accesses? Do I have different layers of connection? That's part of the malware injection, folks. It's something we have to deal with, even on a personal level, as I said. This is also part of a business as usual cloud, sorry, but also personal. So it's an important thing. And one that we are not that aware of, folks, that it happens a lot in cloud. I've seen this a lot among my customers. It's the insider threat. How many times you have seen or you have read about someone stealing information and then selling them out, right? Or, I mean, I think like maybe 2-3 months ago, there was a major robber of information happening somewhere in the UK because one of the former employees decided to use his still active account to steal information and then sell it away. That's something that we have to deal with, right? I'm going to end the poll now, just FYI. So it is important that we consider that we also have to protect ourselves, from our employees, from our people, even from our co-workers. Something important, folks. An insider threat might not be a malintentioned attack. That's an important thing to remember. When we talk about cloud, if we don't have a proper definition of permissions, access, and control, someone might spill the information, some data spillage, just because they click on the wrong button, right? Or they send the wrong email. How many times has that have happened to you? I can tell how many I won't, because that will be embarrassing, but how many times I sent an email to someone that was not supposed to see the information I was sharing with, right? So that's an example of an insider threat. It's not always a malintentioned action, but it could happen, okay? And the final one that we usually face in cloud, I mean, remember, this is just to know what we have in cloud, is a side channel attack. When we talk about a side channel, this is a little bit more complex, but happens a lot in cloud, is when a process, a workload, actually emits some kind of information beyond the actual purpose. Imagine this. I'm sending you a video conference recording, this recording. Okay, good. What you actually want is the recording, right? The session, the recording of myself explaining the stuff and the questions and everything. But that information I'm sending to you has some extra information, right? A size, a format, an encoding process, right? A codex to play it. Well, that information can be used to determine the type of information it's been shared and decide if it should be tried to get retrieved by an attacker. Hey, the size seems to be big, so it might be a large database or a large piece of information. Let's retrieve that. Let's steal that however we can. That's the idea of a side channel attack, folks. In the cloud, there are a lot of tools to shield, to protect this type of information. You can hash code behind an actual solution the size of a file, or you can hash code the actual codex or the encryption layer. The idea is to try to protect everything, not only the actual information, but everything related that gives the context to that information. These first 10 minutes, folks, were about some common things that we will face. I know this is maybe common knowledge, something that you will interpret it as part of any technological platform, not only the cloud. But how do we put this in cloud? How do we use this when we try to secure the cloud, right? Let's talk about here a few of the concepts that come with cloud. Important, remember, this is an agnostic session. That means we're talking about any cloud solution you may use. I saw some of you are using Azure, some of you are using Google, some of you are using AWS on the poll, but it's important you know what we're gonna check now, it actually applies for anything, okay? First of all, and this sounds a little bit dramatic, if you will, but trust no one. You shouldn't trust anyone just because says who it is. No, zero trust methodology. Trust no one, verify everything. When you log into your Azure account, your AWS account, and you open a new tab on the same browser you're using to access your virtual machine, to access your storage account, to access your storage bucket, if you take a look at the address bar, you'll see you're authenticated again. Your user, even though you're already in and authenticated, will be challenged once more time. And we'll go and say, okay, user, password, tokens. It seems that it's a Sturo. Let's provide the access, grant or deny the access. That usually happens in all the cloud environments. By default, you don't have to do anything. The idea here, folks, is that we try to reduce the capacity of access. There is something called the least privilege access, folks. Why will I give to someone an access to the whole computer if that person only needs access to one folder, right? Or why will I give you or someone else access to all the computers if they only need access to one? That's the least privilege. Reduce as much as possible. That's the first concept of cloud. The second one, always assume the bridge. I know, again, it sounds dramatic. It sounds like overreacting, but hey, it's important. If we assume the bridge, we will be prepared to react, to prevent, and to be ready for the next time. Assuming a bridge, folks, when you notice something weird, something that is not working the way you assume it will work, it actually gives you the chance of being prepared or even be over-prepared. That's the idea here. And take a look on the image we have on screen, folks. A lot of bitables, a lot of different concepts play part of this zero trust methodology. Try to always challenge everything. Don't give anything by grant. Okay? Now, this follows with a concept called the defense in depth or the onion principle. I prefer defense in depth. I love onions, but defense in depth it is. If you ever see something referring to the onion principle, is this one. Basically, my friends, it's a multi-layer approach where you add layer over layer of security to the point of physical access to grant that in case of an attempt of penetration or attack, the attacker or attackers will have to go through a lot of different layers to get your information. Remember, most of the times, I will dare to say 99% of the times, the actual target or the end objective of an attack is to retrieve information for misusage of it or to hijack and ask for a ransom or whatever purpose the attacker might have, but the data is usually the final target, right? Well, if we talk about these different layers, folks, every cloud product offers a lot of security by default. This means that the moment you create a subscription, you have security in place. All these layers are covered. There could be more layers added or configured by you. We will see this again. But think about this. Let's say you're using Azure. I see 5 or 6 of you are using Azure today. Well, we have a lot of regions. We have a lot of locations around the United States and the world. If by any chances you happen to find one of the addresses and you just swing by and say, hey guys, I'm a huge fan of your product. Can I have a tour? They won't let you in for sure. They may receive you like, welcome. Yes, here you have a, I don't know, you have a shirt, you have a pen, you have something. Go back on your way because you cannot access. Physically speaking, you cannot access a data center, only allowed people. Google, for example, has a 24/7 role of people monitoring their facilities, every data center they have. Physically speaking, you are protected. You go to the identity. The user has to use a user and a password, or a FIDO access, or an advanced configuration access. You go to the perimeter in the network. You put a firewall on the layer 7, a firewall on the layer 5, and you start configuring different layers on the network. Now we're talking about a logic network, not a physical network, all the way down to encrypting the data, right? To adding some backups or continuity plans for the storage. That's what you do. That's the idea of using this type of penetration approach, the multi-layer approach, folks. Remember, this has been recorded. You can watch this diagram again anytime, but it's just for you to know how we start. The second thing that we have to deal with when we talk about security, folks, is the CIA approach, not the CIA you're thinking. It's confidentiality, integrity, and availability, okay? You will remember this again. So CIA, folks, a way to think about security trade-offs. Basically is, hey, if you trust me and my product, let's say AWS, I will grant you, correct, as Stephen mentioned, the CIA uses the CIA for sure, or at least I hope so. So you have the CIA. By the way, let me launch the second poll, folks. You'll see it running here on the screen. So I subscribe to an AWS, let's say, 3-month subscription trial. It doesn't matter it's a trial. It doesn't matter it's the first time I'm using it. It doesn't matter I'm not paying. Amazon will provide for me a confidentiality agreement. Everything I put in there is confidential. If I have personal information, medical information, contact information, that's protected, always. There is a contract, an agreement offered by all the cloud vendors today that will give to you pages and pages of how they keep your information confidential. The next thing is available. Okay, you're saying my information is protected, but what if I need it immediately? Don't worry, you got it. You need to retrieve 10 gigabytes, 1 terabyte, 2 megabytes of information, you have it. Depending on how you store it, the time might vary, maybe a few minutes, a couple of hours, a few days, but it's there. It's not like Amazon, Google, or Microsoft will hide your information and will give it to you whenever they want. No, it's always available. And the integrity. That means that whatever changes you made, whatever requests you had, will be there. You won't have to worry about outdated information, misinformation, missing information, etc. The idea of using the CIA principle comes from, hey, whatever I put in cloud will always be protected. That's the core of this concept, the CIA. Okay? Remember it, you'll remember it now. I know you will because of the acronym, but it's important we have that approach. If we are offering a service through cloud to a customer, we know that we can grant this CIA approach because it's already offered to us by the subscription we're using, Google, Azure, AWS. Okay? That's the next concept. And the third important concept of security, it's the shared responsibility model. This is my favorite topic because we could discuss this for hours. What is this, folks? This means that you have some responsibility, but the provider will also have responsibility. Take a look on the diagram. Check the right column, on-premises. If you have an on-premises solution running today in your office or at a customer's location, who's responsible of keeping it safe? Who has to clean the servers? Physically speaking, dust them out and also swiping the floor. Who has to keep them cool? Who has to keep the video recording in place? Who has to secure the door, the access? You, right? Maybe you might have someone to do that, but it's physically and conceptually speaking, your responsibility, folks. When we move into cloud, we start giving away some of this responsibility or handing over to the vendor. If we go to infrastructure as a service, imagine that you have a virtual machine running. We're going to talk about that on the next slide, but think about you create a virtual computer in the cloud, okay? The host, the server, the cables, the network, the rack, the access, the cooling system, the dusting out, it's not longer your responsibility. Check what we're handing over. Physical host, physical network, physical data center. We still have the responsibility of the operating system. What kind of computer you want? A Windows Server 2016, good. What happens if the Windows Server 2016 fails to update? What happens if when you try to do something on the server, because you were missing that update, it fails and there is a security breach? Who's responsible of that? Checking the diagram, it was you. Why? Because you decided to handle the whole computer. Operating system, updates, bug fixes, patches, etc. And you keep moving up. You see, you can see we have some other controls. When we move into platform, we hand over that operating system, that actual computer management to the provider. So, as I was saying, what if I create an application? You'll have to be careful because the application, folks, will actually run online with people accessing, registering, answering, and you'll record all the inputs, right? You'll use that to say, hey, it looks like my customers are happy with my product. Good. But guess what? The computer, the operating system, the storage capacity, the time of response was never your deal. Azure, AWS, Google took care of that. It was something that you handed over so you could focus on the actual experience of the application. That's platform. Check the small divided squares on platform, network, application, and identity. Why these are divided? Microsoft, Amazon, and Google will give you a tool to enforce the password, right? But if you don't ask your users to use something complicated and they decide to use ABC 1, 2, 3, whose fault is that? You were given with the tools. That's the vendor part. But you were not using it properly, or you just didn't know. I'm not saying it was on purpose. If that happens, folks, well, we have to deal with it, right? That's the second part that we get. And the third one, folks, that we have, it's the software as a service. You get a computer, you get a solution, you get an application. Let me restart here because I'm getting a message from there. You should be seeing it. Just pop it up. If you have an issue with my screen, just let me know. But I was saying software, you pay for something. Imagine you're using Microsoft Teams, or imagine you're using Google Meet. You're not going to use Teams to create a database, right? Or you're not going to use Google Meet to create a computer. It's for the purpose of having a meeting, a discussion, a conversation, right? Well, if that happens, folks, if that's what's happening, your security is who accesses what and how is it used. If you forgot to put a password to access the meeting, that was you. If you forgot to send the proper time and it got confused and you have someone else there joining on the wrong time and having access to something that was not supposed to be accessed, it was yours. The shared responsibility model, folks, is one of the most important layers of security. We have to remember what is our responsibility, what is the vendor's responsibility, okay? That's a key part of the security in cloud. A lot of the things that we are used to work with on premises are no longer in our scope, are now offered by default with our subscription. So again, read the agreement, see what you have in place, and see what you can add if needed. Okay? So that's the next one we have. Let's talk about something pretty important. The identity as the new perimeter. Those of you with more than 10 years of experience won't let me lie. You may remember the first, let's say, times where we got access to an online service via mobile devices. Some of you may remember, right? There used to be a time in the past where having a smart device wasn't cheap and was a complete pain for the people in IT to secure. Having a mobile device, folks, in the past to access your email or a private network of your company will be really hard to configure the first time because of the complexity of one device granting the access, another device challenging the access, and just using one by one. That was 10 years ago. That was maybe 15 years ago, if you will, if we go a little bit far back. Today, folks, everyone has a smart device, at least one, right? Today, everyone can access whatever information they want the moment they need it, if they have a connection, as I said. If you need to look for something, you immediately just ask your assistant device or you just like type it down and you have the access. Now think about this on a corporate environment. I need to access the last KPIs. You just look for the folder and you get the immediate access, right? How do we secure this type of bindable access? Given that we don't have a perimeter network, we don't have an office shielded by a network, how do I do this? With the identities, folks. Identity has become the main security or the first security layer to configure. It's the new perimeter. I don't care where are you, what device you're using, how are you accessing. What I care is your user, your identity, and the permissions that identity has. You can be connecting today from the United States, from the UK, from India, using your mobile, using a landed laptop, using a smart device in India. I don't care. You will use your same user, right? Arturo.hamilton@company.com. Well, I'll be protecting the access, the information by securing that authentication. That's why it's so important in cloud, folks. We will have a chance in the future. I'm going to show you a few options to continue learning, but there are classes, 4 or 5 days classes, fully dedicated just to protect the identities. How to challenge the access, how to confirm that it's who's talking or who's mentioning it is. For example, just a quick example of this. A few years ago, I lost my phone in Brazil. I was running to catch a flight and I dropped my phone. I never realized I dropped my phone. 2 days later, someone was trying to access from Nigeria with my phone. Given that I've never been in Nigeria, the closest I've been might be Morocco, automatically Azure said, Arturo has never been there. He just connected an hour ago from Mexico City. How is it possible that he's logging from Nigeria in less than an hour? That's an impossible travel, physically speaking. Automatically, the service knew that it wasn't me. It blocked my account. It completely wiped that device that got robbed. Well, not robbed, someone found it. And it sent a notification to the administrators to say, hey, Arturo seems to have an issue with the access control. That's it. That's an example of the security perimeter. Now focus on the identity, folks. The second layer that we should protect in cloud, identity being the first one, remember that, take a note of this one, folks. But the second one is the computing and the host, or host, sorry. I skipped one here. 99% of the users in cloud, folks, have a computer, a virtual machine, okay? An EC2 solution, a host. Why it's all common? Because it's what we know, right? The first time we use a cloud solution, it's create a computer, get an operating system, let's see how it looks. Okay, we can use it. That's usually the approach. Now, computing, folks, the host security usually follows the idea of deploying on something called the non-monolithic approach. I know it sounds weird, but think about a single stone, carving from a single stone. If we do that, we have a computer with the code, the database, the application, the front end, the back end, the communication, everything in one single computer, right? We don't want that. Okay, what should we do? Segregate them. Add two computers in different networks, in different soft networks, in different layers. That way, if one of them gets compromised, the other one may be safe, right? We might have enough time to protect the second one, or they are so isolated from each other that nothing will happen to the second one. That's the principle of computing host. Another option that we have here, folks, is always test the services. For example, I travel a lot to teach again after the pandemic. I'm actually leaving next week to deliver a class in Puerto Rico. And instead of using or traveling with a huge laptop, I just bring a small Surface, and I have two computers running in Azure, one in Azure and one in AWS, that I connect remotely, where I can use all the applications I usually have for teaching. The first time I did that, one of those was not actually updated. When I tried to access, I realized it had been hijacked and it had been used for cryptocurrency mining. My computer had been running for like 3 days or 4 days because I never tested the access before using it again. I spent like $300 on computing because it was using all the power that could, just because I forgot to test the access. That happens. That was like 8 years ago, but it happens. That's why it's important. Always test them. Check them out regularly. If it's working, okay, you don't have to change it. Just confirm that's still working the way it's supposed to. Segregate the APIs too, folks. If we create an application, if we create a solution that it's, let's say, related to the computer somehow, but it's not the actual computer, put it somewhere else. Try to have a different type of access, a different type of control, and then make them talk to each other in a different level. That's easier. And always try to keep the connections safe. I'm going to talk about connections in a minute when we get into network, but it's important. The other host that we have, I'm not going to get into much of it at all because this is a discussion that could take us the whole day, are the containers. We can create Kubernetes, we can create KRS, we can create Mesosphere, we can use Docker, we can use ACI, AWS, we can use tons of different options, right? The idea of using containers, folks, is to have small building pieces that together will do something, an application execution. When we use containers, this is the important part of this specific note. The vendor, Microsoft, Amazon, Google, will take care of the security of the host, the computer itself, the virtual machine hosting the containers. You are responsible of the small pieces working as expected and being secured for any purpose that they may have, talking to each other, connecting to each other, retrieving, receiving, sending information. We have an operating system that is handled by the vendor. That's good. We have a deployment. We take care of that deployment, those objects working together. We have a storage to protect, right? Where do I have my information, my assets, my database? I can protect that. Google will take care of the computer. Microsoft will take care of the computer. The idea of a container, and again, this is not a security discussion, but it's for you to know, it's to reduce the dependency of an actual virtual computer and segregate them, as I said, isolate them, separating all the options, all the objects that are part of a major solution. That's the idea in here, folks, okay? That's the basic for computing. Now, network. If you ask any security architect like myself, they will tell you network is the most complicated part to secure. Why? Because virtual networks, folks, are pretty complex, are huge. A virtual network, folks, can span across the whole world. For example, in Google, you can create a network that starts in the United States and spans through all Europe and goes all the way down, maybe, let's say, to Africa. It's that huge. You can have a pretty small network created in Azure, isolated to one region, let's say South Central, and you will have it somewhere around Houston. A small network there, that's good. Or a worldwide network, as I said, with AWS or Google. That's why it's so complicated. A network can be public, anyone can access, can be private, only authenticated users can access. What's the complexity of this? That you have to deal with both. You have to make them visible to each other. You have to be able to reach them if needed. And you have to make them safe. Take a look at this. We're not going to go into all these details. It's just for you to know. This is the list of things that we could add to one of these services for a network security solution. Dynamic addresses. Let's be sure that the address that I use for the application to work today, it's different tomorrow. In case of someone identifying the proper IP, tomorrow that will be useless. Let's do that. Or let's pay for a reserved IP that I bought as a company, as a user, to be the same IP always, because I have all the security monitoring that specific address. Another option. Let's have balancers. Let's be sure that anyone who accesses an application in cloud, it's redirected to the closest answering computer. If you connect from the States, where in the States are you? On the East Coast, on the West Coast, on the northern part, on the southern part. And based on that, a balancer will put you to the closest location so your petition is not running around the United States with the chances of being hijacked or being listened to, right? That's the idea. We have, for example, the option of creating a lot of soft networks. One soft network for databases, one soft network for the application we're going to expose, one soft network for the computers. So in case of a penetration, one of the actual objects is, let's say, compromised, but the others are safe. The same that I said with the segmentation of computers, you see? That's the other option that we get, folks. When we add this type of security, we start adding, we start putting together different layers just on the network. Remember the principle of the difference in depth? Well, this is difference in depth just for the network layer. There is a class, for example, the Azure Security class, the AC500. I'll show you this list at the end, but the AC500 has a full day, 8 hours, to build a network security solution. From the top to the bottom, at the end of that day, for example, you have like 20 different services working to protect one computer, just on the network layer. That's the complexity of it, okay? And one of the benefits of this offered by the three vendors is that if you connect your network, your actual office, let's say your head office or your whatever, let's say your branch to AWS, you can protect the virtual network in AWS and keep the security of your own premises the way you already have it. Make them talk to each other so both security definitions are compatible, that you don't have to deal with a complete reconfiguration just because what I had is not actually compatible with what I have now, the new things that I'm creating. No, using virtual networks with the security of cloud are fully compatible and understandable by on-premises features. That's the benefit of this. We are prepared to tackle them if needed. Let me end the second poll and we'll get the third one in a minute, okay? So that's our network, folks. Again, we can discuss every one of these topics in a complete day of training, just for you to know, okay? And the last one that we have on the main layers, it's the storage. Storage is used by everyone. The things that we saw on this lesson up to this moment are always in place. A computer or something to compute, a user, a network, and something to store, always. These three objects plus the identity are always part of a cloud solution. That's why we discuss this as the foundation of security. The storage, folks, it's, I will dare to say, the easiest to secure because it's pretty simple. Use encryption. Microsoft, Amazon, and Google will encrypt your objects the moment you put them in cloud. If you upload a picture, if you upload a video, it will be encrypted. For sure, the moment exists in cloud, in that moment is created and encrypted, always. You don't have to do anything extra, but you can add extra encryption. I'm going to show you a little bit of encryption on the next module. Replicate, keep a copy of it, right? If it's important, why do you have one single copy? Why don't you create another copy? There are services, free services, paid services, premium services in the three clouds that you can use to create automatic copies every time there is a change, or create a copy to run every day at 8 p.m., or to have a copy taking place every week, or to get 3 copies per hour. It can be automated for databases, for storage accounts, for buckets. The idea is that, hey, if this is important, let's keep it on redundancy approaches, right? That's the idea of storage. One of the most important parts of storage, folks, is the encryption. As I said, when we talk about encryption, we can use symmetric or asymmetric. I'm mentioning this because the vendors will offer you the two options. Symmetric means that the same key you use to encrypt, let's say close, you use it to decrypt, to open. On the other hand, when used the asymmetric, you have one key to close and a different key to open. This type of encryption can be granted to your information address. That means when you're not using it, when it's actually sitting there nice and pretty waiting to be used, or while the information is actually used by you. That's the idea of encryption, folks. And this sits on the storage. So we're back to the onion. Now you see, we're here again, defense in depth, but with some of the things that we discuss. We have some conditional access. Remember the example I gave you of my phone being used in Africa? Well, conditional access blocked that from Azure. We have a firewall on the network, as I said, on the layer 7, facing the internet petitions. We have some security on the operating system, plus the Kubernetes on the host. We have some advanced data encryption on the data and on the application. You see, we have these features that we mentioned distributed to the different layers of defense in depth. Okay, this is just a brief overview of what security can, what type of security features or what security will be when we sit in the cloud. Let's wrap up this by talking about the best practices. I'm gonna launch the last poll. It's here now. So if you give me a hand with that, folks, please, while we discuss the best practices. First of all, and most important, understand the responsibility model. Remember the diagram I shown with all the different blocks? Always remember that, because I'm not saying that the vendor won't help you. I'm saying that if you don't understand what was yours and what was the vendor's responsibility, you may have some rough times ahead of you, right? Like, hey, why is this not working, my friend? That wasn't yours, or that was not Microsoft's or Amazon's responsibility. It was yours, my friend. You should have done something. So be quite aware of the responsibility limitations of the shared responsibility model. Ask about the specifics from your vendor, folks. Hey, Microsoft, how do I encrypt my storage account? Hey, Amazon, how do I create a routing table for the connections that are coming outside of the United States? Hey, Google, don't wake up. I also have the Google device here. So, hey, how do I actually protect all the data that I had on the data on these SQL databases that I created? Be specific. If it's there, they will guide you. If it's not there, they will help you to understand how you can do it. Deploy identity control, folks. As I said, identity should be your first perimeter. Deploy whatever you have on hand or whatever you can reach to protect the identity. Keep your people trained, folks. I'm going to show you in 3 more minutes all the different trainings we have here at Sunset for Amazon and Microsoft. There is free training online. There are free webinars like this taking place in Sunset every time. So keep training, keep learning. I mean, maybe 45 minutes were enough to say, hey, I need to focus on my identities, right? Or as Stephen said, okay, the CIA uses the CIA, so I should use the CIA. Stuff like that. Keep always trying to learn new stuff. Just to give you a context, folks, Microsoft, Amazon, and Google together invest more than $2 trillion in the last 5 years to improve their security offerings. So that's how many new things are coming up every year. There are a lot of things happening every day, so take a look at them. Establish the policies, define who can create, who can access, who can modify, who can delete, define the policies for password, define the policies for access control, define the policies for creation. Who should be able to create a new computer? Who should be able to modify the storage configuration? Secure the endpoints. If you have an endpoint, an application, a database, try to put security on that. Besides all the things we said, identities, networks, storage, go to the endpoint too. Encrypt the data. At rest is already encrypted by the vendor, but encrypt the data while it's moving, while it's transferring. Use HTTPS protocols. Use some advanced security integration. Use VPNs. Use end-to-end encryption using ExpressRoute, Direct Connect. Stuff like that can be used for the communication on the wire. Try to have prevention in place, folks. I know that we love to react and learn from it, but if you can, try to learn beforehand so you can prevent. You can use a SIEM. You can use a SOAR, like Splunk from Cisco, or you can use the one from Microsoft, Sentinel. Azure Sentinel can monitor and prevent AWS and Google intrusions. We can use CloudTrail, for example, in Amazon to do the same, but now from Amazon to Microsoft and Google. We can use Google Monitoring Security Safe. The idea here is that keep an eye, learn from it. And finally, folks, double check, always double check. We as humans have the, let's say, I wouldn't say tradition, right? But we're used to actually like just create something and see what happens on its own. And then we will figure it out on the road, right? If something happens, we will see. Double check it first. If you're compliant to what you need, what the government needs, what the customer needs, consider always having advanced solutions, audit, monitor. There are a lot of monitoring tools you can use for free, paid versions, etc. And finally, folks, always double check your configurations. A lot of issues I've seen in the past, a lot of issues I'll see in the future, I'm pretty sure will be due to misconfiguration. My own misconfiguration, your misconfiguration, a misunderstanding of a configuration service. You forgot to tick or to check or to actually click on something. And that small click might be the root of a pretty big, let's say, issue taking place in the future because it was some type of configuration control. These are some best practices. There are more. Depending on the cloud, you'll have more, but this is for you to have a first approach and understanding of our features. Now, folks, we have been here for 45 minutes now with the theory. We're done with the theory, folks. If you have questions, now it's time. Ask anything you want. If you want to ask something specific about a product, as I said, I'm an architect on the Trick Cloud, so I can help you. Or if you have a general question, please shoot me on the chat. Shoot us on the question and answer section. In the meantime, folks, what you think, if you have any questions, remember that the next steps are to keep learning, right? We have a lot of security classes, a lot of offerings here at Sunset that you can take with us. We have from the foundations of security, the essentials class of AWS, or the SC900, that is the fundamentals, to specialist classes. For example, for those of you using Azure, you want to learn how to protect the identities, your class will be the SC300. 4 days of protecting users. You want to learn how to protect the information, how to add labels, how to add expiration dates and periods. You can use the AC400 class to learn about it. That kind of learning, folks, is always useful. Security is one of the most important parts of a technology approach. And as I said, we can take them both in here. We have special webinars coming up in the next few weeks and months. You'll see some a little bit more focus on specific clouds, some foundations of Azure, foundations of AWS, advanced security. This is a sneak peek, a spoiler. I think our friends here at Sunset will be mad at me, but we have some artificial intelligence for security coming up in the next months. We will see about artificial intelligence being used to prevent, to detect, and to mitigate. So we will have those webinars running for free in the next upcoming months. So keep an eye on the announcements that we have. The next webinar we have right now, the free course that we have on November the 6th, folks, remember, it's about an introduction to AWS. Okay, we have a full overview introduction to the platform, to Amazon Web Services. This is not for security, it's a global overview, a big picture of AWS, but remember, more things are coming in the future, folks. There you can register. We have on the chat the registration link for this webinar that's coming for free the next, I think that will be from this Monday to next one. So be sure to click on the link that we have on the chat and register, folks. Will be an amazing class. Vicky is an amazing instructor, so you'll learn a lot about AWS on the first, just on the first 10 minutes, you'll be like, oh my God, all these things can be done in AWS. Yes. So again, my friends, that's all for the day, for the session of today. I hope that you enjoyed the session. I hope that you learned something. I hope that after you close the webinar, you say, hey, now I remember the CIA. Now I remember the defense in depth, the share monitor, whatever you think that is useful. I really hope you're getting something from today's session. And again, we still have a few minutes. If anyone wants to ask anything, feel free to. I'm going to be here for the next few minutes. If you're done, folks, I appreciate you were here today. I really enjoyed teaching for you these foundations of security in cloud. And I hope to see you the next time on our next security webinar. Anything you need, remember, we're here to help you, folks. And that's officially our session of the day. Thank you very much, folks. Have a great day. Thanks to all of you. Hope you have a great Thursday. Have a great weekend. And I hope to see you the next time. I'll keep an eye on the chat just in case you need anything on the questions. Thank you, folks.